So this is FPGA. Now, our next slide is an slide whose FPGA divided into or provide synthesis and debugging capable, user-friendly, and design process for engineers. Fundamentals. What are the fundamentals? These fundamentals. So let's go about the basic fundamentals. It is about architecture, programmability, parallel processing, and logic. Architecture. First, an array of programmable logic blocks interconnected by configurable routing channels which allows for flexible circuit design. Programmability. Unlike AI, FPGAs can be reprogrammed after manufacturing, enable upgrades or functional features. So, what is parallel processing? In this is the main kind of fundamental which is used in FPGA used for ideal high-speed applications as FPGA can handle multiple tasks because of this parallel processing. Logic comprise basic components like lookup tables, flip-flop, and multiple logic. So these are the basic fundamentals. And next slide is about programming. FPGAs are programmed by the specific language is known as like VHDL or Bitcoin. We had very low hardware difficulty, whereas VHDL is not only specific related to very low, but it's normal hardware description language. These have designers to specify the behavior and of electronics, and the compiled design is then uploaded to configuration memory. So this is a programmable logic, which is again divided into two parts, and that is three programmable devices and three programmable devices. As the programmable devices, further divided into two types, that is ROM and INT. ROM is read-only memory and FPGA is mass programmable. Whereas these programmable devices are three types: SPLD, CPLD, SPLD is simple programmable logic device. Here is complex programmable logic device. FPGA is field programmable device. Whereas SPLD is simple programmable logic device. It's code divided in four types: ROM, PLA, EAL, GAL. And programmable read-only memory, programmable programmable logic, and generic array logic. So compiled design is then uploaded into the FPGA configuration command. So this is how do we do programming in FPGA. So let's know what is advanced features of FPGA, because that's the main topic of our presentation. So we will know that high performance DSP blocks. This enables FPGAs to perform digital signal processing tasks crucial for industrial applications which require real-time data analysis. The second one is embedded processors and support. This is used to integrate with hard or soft processor cores such as ARM, complex processing, additional microcontrollers. The third feature is high-speed input-output and transceivers. This is to facilitate fast data for applications in data centers, telecommunications, and industrial networking. And we have one more feature known as AINNL acceleration. And this is machine learning and artificial intelligence accelerates. This future support deep learning tasks by optimizing hardware for mission learning workloads, increasingly common in industrial automation. So this is the advancement of FPGA. So let us know what are the advantages of using FPGA. Why should we use FPGA over AI and IC? Let us know about it. Because of its reprogrammability. FPGAs can be reconfigured multiple times, allowing flexibility for updates or new functionality. Parallel processing. Ideal for tasks requiring high-speed computing as FPGAs handle multiple operations at low latency, provides faster response, essential for real-time applications. High customization, tailored design enables specific performance optimization. Last feature and advantage is cost effective for prototypes, avoid high initial cost of active AIC development. So these are the reasons of it that we understood in this slide. Yes. So let us know what are the limitations of FPGAs. Whereas like every thing has pros and cons. So if it has the features, the advanced features and many advantages and many set points, the pros, it obviously have the limitations and cons. Let us see what are the limitations of FPGAs. FPGAs may have high power consumption compared to AICs for specific applications. They can also be more expensive for high volume production compared to custom systems. The learning curve for programming FPGAs can be steep for beginners. So as we see right from the picture, we can see total power consumption. So it's always like everything has a limitation. There's no the graph goes up and down and up and down. If there's no stable power consumption, there's no stable. It has a but it has a better and higher power consumption compared to the AI for particular applications and specific applications. So that is why we use FPGAs are kind of limited. So now let us see what is FPGA development ecosystem. The FPGA development ecosystem includes hardware, software, and community support. Manufacturers offer development boards tailored for specific applications and prototyping. Like as we see in this picture, this is the FPGA development ecosystem. This is how the circuit will be in the real. So, an online forums and resources provide valuable information and troubleshooting assistance. So, for FPGA development ecosystem, this all are the things, and this is what is all about the development ecosystem of FPGA. So, let us know what are the challenges in implementation of FPGA. Implementing FPGA design can pose challenges such as timing closure and resource utilization. Designers must balance performance with available resources on the FPGA. Debugging complex designs can also be time consuming and requires effort. So as we see here, the design will have simulation and then comes synthesis. In synthesis also will be the simulation process will undergo, then implementation and this also simulation process will undergo and then we program the FPGA, the final output. So implementation challenges are comparatively harder uh, and challenging for as it has timing closure and also it is used for it should be used for resources and for using resources because decom- de- debugging complex designs and time consuming also requires very much expertise. So this is why we have implementation challenges in FPGA. So let us know what are the key applications of FPGA. What are the basic applications? Mission, mission vision, and inspection. FPGAs process image data, which is crucial for automated quality control and defect detection in manufacturing. The second one is signal processing in measurement instruments. Enable accurate data, precision, filtering, and analysis, which is important in complex systems like oscilloscopes and medical devices. It also is used in data security, used for real-time encryption and decryption. FPGAs help secure industrial data essential for protecting intellectual property. Motor control. FPGAs offered precise control over motor speed and position, essential in automation and robotics. Power electronics. Used in power converters and inverters. FPGAs enable efficient and fast control, leading to energy savings and improved reliability. So it is also used in power electronics. This also the main one is key application of this is industrial networking. And that is what is the topic for today. With support for protocols like Ethernet and real-time processing, FPGAs enhance communication in industrial networks. Example, IIoT, Industrial Internet of Things. So these are the key applications of FPGA. So how is it used in industrial electronics? Let us see what are the applications in industrial electronics. FPGAs are widely used in industrial automation systems for real-time processing. They play a very crucial role in signal processing applications such as image and audio processing. Their adaptability makes them very suitable for custom and control systems and robots. As we see in the picture over here, FPGA applications are wireless communication, aerospace and defense, video and image processing, security system, consumer electronics, distributed monitoring systems, scientific instruments, and medical electronics. So these are all the applications that as we have seen in the previous slide already. So I just kept it here so that it will be more easier to understand what are the applications of FPGA. So let us know what are the future trends in FPGA technology. The emerging trends include the integration of FPGAs with AI and machine learning capabilities. The development of smaller, more power efficient FPGAs is on the rise. The growing demand for the edge computing is driving innovation in FPGA applications. So as we see, FPGA technology is very demanding and very demanded and very useful in today's generation and today's uh, world because it is integrated with AI and machine learning, which is the most thing in today's technology. Like artificial intelligence and machine learning are playing a very major and a vital role in today's world. Like people are not able to survive without this because even food from the food we eat to the things we do to the job we do, AI/ML plays a very big role in all the things because AI/ML has have the growing demand in today's generation and FPGA is integrated with it. So even FPGA has a good future. So there is having a good and efficient future. So FPGA has a very good technology and very good future because it is integrated with AI. And so let us see a case study in industrial automation. In industrial automation, FPGAs facilitate the execution of complex control algorithms. They can process inputs from multiple sensors simultaneously for improved accuracy. The Functionality of FPGAs allows for quick adaptation to new automation standards. So this is the um, FPGA in industrial automation or industrial electronics. There is a case study we have seen and we have studied now. So moving on to our next slide. So now I'm going to conclude our presentation with this slide. In conclusion, we see that FPGAs are essential to modern industrial electronics, offering unmatched flexibility, processing power, and adaptability. Their reprogrammable nature, parallel processing capabilities, and integration of advanced features like DSP blocks, high speed I/O, that is input and output, and AI acceleration, that is artificial intelligence acceleration, make them individual across applications. From motor control to industrial networking and machine vision, FPGAs enable precise real-time processing. As industrial demand keeps growing, FPGAs will also continue to drive innovation and enhancing the efficiency, customization, and longevity in automated and high-performance environments. So this is how, in conclusion, we'll know that FPGA has a very good and a very high demand in industrial electronics and also in many fields because it is integrated with AI/ML. That is what we understand because of its reprogrammable nature, and parallel processing capabilities, and also because of its input, high speed input and output, and also because of its advanced features like DSP blocks. So we see that it has a very good demand in the growing and present generation and also in the future generation. So that is what the my presentation is all about. Thank you, ma'am, for giving me this great opportunity. I really like to thank you once again for this wonderful opportunity, as it helped me learning and getting to know much more about what FPGA is, and also because of its applications and everything. Thank you once again, ma'am. I hope you like my presentation. Thank you.